welcome, buenos dias, to my talk, Zero Downtime, Zero Worries. It's about the Kubernetes deployment strategies and traffic management. But before we start, let me introduce myself. I'm Stefanie, I'm originally from Germany, and right now I'm doing a gap year. So I'm actually traveling around the world, but I'm not only doing that, I'm also staying hands-on. I started participating in some meetups, and that's how I actually get to know KCD in Mexico. And after that, I decided to apply as a speaker in the KCD in Antigua in Guatemala, where I already did this talk, so this is my second time. And yeah, now I'm here. And in general, I'm passionate about DevOps, clean code, and hiking adventures. So I'm very looking forward to go hiking here in Bogota, actually, after the KCD. So what's our agenda? First, we will talk about the Kubernetes building blocks. Then we talk about 5 different deployment strategies, also about traffic management with ISTO. And in the end, if we have time, we will talk about the monitoring and the CI/CD with Argo CD. Yeah, so let's jump into the building blocks. So in general, the basic components in a Kubernetes cluster is a deployment with the pods and the service. So the deployment is administrating the pods. You can define how many replicas you want to have of a pod, and the pod is holding the containers. You can have multiple containers in one pod, and it's encapsulating your microservices. The service, the Kubernetes service, is exposing these pods for the user or for the other Kubernetes pods to make requests to your pods. Exactly. How does it look like in the code? So we have some general data, API version, kind, metadata, and spec. These are required in every Kubernetes manifest file. And what's special about the service is this selector here. So with this selector, the service is choosing to which pod it is forwarding the traffic. So here we have in this curly braces, we define the label which has to be attached to the pod so that the traffic is forwarded to it. This curly bracelets is actually from Helm. That's a package manager. And later on, there's actually a talk about Helm and some AI chatbot, I think, or AI agent. You can check it out later if you want to. So here we have our deployments. We see that it has 7 replicas of 7 pods in line 7, I think, yeah. And then we have the labels 2 times in line 8 and line 12. That is because the first time it's defining what, it's again a label selector, it's defining what pods belongs to the deployment, and everything under template is actually the pods. So here we have the pod label, which is important for the service also to do the traffic. And on the bottom, we have our container defined. Here we have a simply HTTP echo image, which is just echoing this text here, hello from KCD revision 1, for example. And then we define a port as well. Welcome everyone. We just finished the building blocks, then we will continue with the deployment strategies. So today we want to talk about 5 different strategies. We create ramped, blue-green, canary, and A/B testing. We go through them one by one. So recreate is a very simple one. We just terminate all our pods, as you can see here in the animation, and then we ramp up the new version. So in this deployment strategy, we actually have some downtime because we terminate all the pods, and then we need to wait until the new version is up. How does it look like in the code? In the deployment resource, we just add the strategy. So very simple, just 2 lines. And that's how we have this simple deployment strategy. It's actually just for use cases where you don't need a high availability. That means that you don't need your application to be running all the time. It's okay to have some downtime. And also if you have limited node resources where you cannot have like more replicas than this tree, you can decide, okay, I have not enough resources in my cluster, I will just shut it down quickly and run it up again. Yeah, but not so recommended in production actually. The default deployment strategy, the default deployment strategy is a ramped strategy. It's also known as a rolling update. And yeah, you actually don't need to define anything at the deployment resource because it's already there by default. But you can configure some parameters, max unavailable and max search. With max unavailable, you define how many pods can be unavailable during the deployment. So for example, you have 3 replicas, you say 1 can be unavailable, so there always need to be 2 pods running. Max search is the opposite more or less. There you decide how many pods can be above your replica count. So when you have 3 pods again, you say you have 1 max search, so you can have in total 4 pods running. And that's actually how you can also speed up your rollout. Your deployment. Let's see this in the animation. On the right you have the code actually which you can add. And now we see that 1 is unavailable now, we have 2, and then we ramped up 2 new. So we have 4, which is a max search of 1. And then after that we can terminate the last 2 pods of the old version. So the other 2 remains of the new version and we run up the last one. Exactly. So here we have minimum 2, then 2 new are running up, we have 4, and now we can remove this, we have 2 again, and we pull up the last pod and we have 3 replicas of the new version. That's the default, and yeah, you can play with the parameters to speed it up. If you have the max unavailability to the same number as the replica count, to 3 in this case, that means that you can have a minimum of 0 pods, and that's actually resulting in the recreate strategy and to some downtime, because that means that all pods are getting terminated at once. Yeah. Now we have our third deployment strategy, blue-green. This is actually when we want to control it more, the deployment, the traffic management. So what we want to do, we want to have an instant switch. We don't want to wait for the rolling out, but we have already our two releases. We have them running in parallel, simultaneously. So we have one deployment with the color blue and with the color green. And for this, to have this instant switch of traffic, we actually use the label selector of the service. And we not only have the app label in line 7, which we have seen before, but we add the color label. And the 2 different deployments are labeled with different colors. And then we just change the label when we want to change from one version to the other. But this means actually that we need more resources because we have the double amount of pods running. Let's see this in the visualization. So, oops, excuse me. So here we have basically our old version labeled with blue and our new version labeled with green. And we just changed the label selector in the service to blue and green. And then we can instantly switch the traffic. We don't need to wait for the pods to roll up. We can just change it, and also we can change it back. So when we notice that in our green deployment there is some mistake, some performance issues, we didn't test it before in staging because we hadn't enough data or we haven't had the proper data, then we can switch back to the old version immediately. So yeah, what did change? We have a color label here, the service selector, and we also have the color labeled here in the deployment. And we have 2 deployments, blue and green. Here's also a different container as we have seen before. Now we're using actually an image from the GitHub container registry with the tag blue or green. Exactly. We can actually see this in a demo. Righty. Okay. Okay, it's loading a little bit. But what we have here is we have 2 deployments with 2 pods each. So we have 2 pods for blue, 2 pods for green. And now we can see that it's like, more or less we can see that it's approaching the blue pods. And when we change the service label, it should approach to the green pods. Yeah, but maybe we can skip this demo. Maybe for the canary deployment it will be stop loading and will be ready. Let's see. Yeah, so this is how we switch the traffic instantly. If we want to have it more gradually, we can use the canary deployment. For that, we also have 2 deployments in parallel already running, the version 1 and version 2, or the stable version and the canary deployment, and we gradually increase the traffic to the canary release, the canary deployment. And this we are doing with some weight-based traffic management, and we're rolling it out gradually. Why is it called canary? Maybe if you're coming from some mountain, mining cities, region, industrial cities, you know that back in the days they used a canary bird to test whether there was gas in the mine. So the bird would actually do some noise and alert the people, okay, get out of here, there's some gas, it's dangerous, something could explode, whatever. And so this is also here the case. We test the new version gradually, we go deeper into the mine, we expose more and more traffic to the new version, and we can test whether the new version is working, and yeah, whether it's stable actually, and whether we can make it to the stable version. So what do we use for this? We have ISTO as a tool to manage traffic. There we have 3 new resources: the gateway, the virtual service, and the destination rule. So the gateway is actually configuring the external traffic. So now we have actually like a service mesh. ISTO is actually very powerful for inter-service communication, and that's why we need a gateway. And the gateway is forwarding our traffic to our virtual service, which is defining the weights to our routes. So we have 2 subsets, version 1, version 2, and the virtual service is defining the weights. And after that, the destination rule is applied, where it's matching the subsets with the label selectors of the pods. So we can see this here in this graphic. So the traffic is coming through the gateway to the virtual service. 80% is forwarded to version 1, 20 to version 2. The destination rule is adding the label selectors. So we have 1 deployment with release stable, 1 with release canary. And the service, we see that it's only have 1 label. So the destination rule is actually adding the 2nd label. And the service is, it's not like in the blue-green deployment, applying the labels, but the virtual service and destination rules are used. How does it look in the code? We have a simple gateway, which is attached in line 9 to the virtual service. And here we can see the routes. So we have the subset version 1 with the weight for version 1. So this is again with Helm. It's getting replaced as a variable with what we define in our values. And then we have the second route, version 2, with the second weight. Then we have the destination rule, which is mapping the version 1 to stable and version 2 to the label canary. And the service, stayed as our very first, is actually the same as in our very first deployment strategies. It only has one label, but the deployment has 2 labels. And we have 2 deployments deployed at the same time. Let's check whether, this is still loading. Okay, oops. Okay. So actually in the demo you could have seen how you can gradually change the weights in the virtual service. So you can manually change the weight from 100 to 0, 80 to 20, 60 to 40, and so on as you like, and also switch it back. And in the end, when you have 0 to 100, so 100% of traffic goes to the new version, you can clean up your setup and terminate the deployment. You don't need to use less resources. The last deployment strategy is A/B testing. There we also use ISTO, but we don't use the weights, but we use the request properties to determine how the traffic is controlled. So A/B testing in general is actually about testing 2 different versions. For example, we have one version of our application with a classy button, and the second version we have more like an animation, like a flashy button, and we want to test the user behavior, whether they use the classy button more or the flashy button. So we split the users into 2 groups, A and B, and then we check, we log or we track how they interact. Exactly, and this we do by the request properties. So we can see here the group A and group B, and we have the default route goes to group A, to the default version of our app, and depending on the cookie and the request header, we forward the different traffic to group B. You can see this in the code here, that here we have the regex. So we have it a little bit different than before, not with the weights, but with this regex here, and we determine that the request has to have a parameter cookie, and this needs to have the cookie needs to have parameter AB test group with B to go to the version 2. This is another example. With the company mail. So here we decide that the request should have an email with the company email, and only the employees get the new version basically for testing. So ISTO is actually a powerful tool to manage your traffic. So next, let's talk about the monitoring tools. We have 3 different tools here in our presentation. There are much more actually. So there's Prometheus for logging aggregation, Kiali, which is actually from Red Hat. There are some people here actually today from Red Hat. This is to visualize these logs, to see the traffic. It's actually especially for ISTO, so you can see how the traffic is forwarded. And then we have Grafana, which is visualizing the health of the cluster, the performance, the CPU, and the memory. But you can also write your own logs and also create your own graphs in Grafana, actually. So, for example, with the A/B testing, you can write some logs whenever a user is pushing a button or whatever, and then you can also visualize this with Grafana. So how does it look like? Here in Kiali, we can see our Canary app, and we can see that we have version 1 and version 2, and we see how much percentage of traffic went to two versions. So here we have 20% to version 1 and 80% to version 2, because we made more requests to version 2. We can also see how long it took and everything. Also, whether there were some requests which failed. It's also it's also visualized in Kiali. So yeah, this traffic graph is actually quite special feature in Kiali, actually, I would say. Next we have Grafana, and yeah, as I said, that's more about the performance, about the memory and the CPU. And here we can also see on the top that the data source is from Prometheus. But I guess there are also other data sources you can use to build up your Grafana board. Yeah. The last topic about today is CI/CD. So there are a lot of actually a lot of GitHub's tool. One of them is Argo CD. There was also a previous talk which approached it a little bit. So with Argo CD, we have two more resources: application and rollouts. And this is actually optimizing our flow, actually. So what we did now before, we did it all manually. We applied our Helm charts to our Minikube cluster and did it all manually. But it is better if you can sync it to your GitHub or your GitLab, whatever. And Argo CD is pulling the changes and applying it to the cluster. Instead of manually applying it to your cluster, you have like a source of truth, and you can also audit it, and you can also reproduce it because you have the version control history. So yeah, you can define the application, where you basically define the location of your Helm charts, or in general the location of your Kubernetes resources, and it will automatically deploy it to your cluster. Then another resource are the rollouts, and there you have more features. So for example, you can define when is the switch happening from blue to green, or back from green to blue. And also for the canary, you can decide, okay, the first step from 100 to 80-20, this will happen manually. Somebody has to click a button. But after that, it will happen gradually. After 20 minutes, it will change from 80-20 to 60-40. After 20 minutes more to 40-20, and so on. So you have some more, you can actually optimize this deployment strategy and plan your rollout with this resource more. Yeah. This is how it looks like in the dashboard. So here we have, for each deployment, we have a tile, and then for the services, we also have a tile. So this is how it looks like for the canary. We have our service over there. We have the destination rule, the gateway, and the virtual service. And when we change the weights, so we make a push to our GitHub repository with the weight changed, then Argo CD will pick this up. It's actually polling it every 3 minutes. It's polling the repo, and it's noticing that there are some changes, and it will redeploy this application with the new changes, and then it will forward the traffic to the canary and the stable version according to these weights. Yeah, that's about it. Happy deploying, and if you have some questions, that's your time.